Okay, making assumptions about data. This is just following on. We're on page 422, still down below. So, first of all, what is an assumption? The word assumption is used often in the English language, but in science it has a very, very specific definition when we're talking about assumptions about an experiment. There are three things. The first thing, a belief that something that you did not control did not affect the experiment. So again, oh dear. Oh dear, and I can't undo that either. Oh, but I have an eraser. There we go, okay. A belief that something that you did not control did not affect the results. Secondly, a belief that the controlled variables were correctly controlled. Again, a belief that the controlled variables were correctly controlled. And thirdly, a belief that the same procedure was followed for all measurements. So let's consider this in terms of our Rocketman lab. Let's look at this first one here. Let's look at this first one. A belief that something that you did not control did not affect the results. Well, if we can consider the fact that we were outside, we obviously couldn't control the wind. And so therefore we did not control that. And so an assumption is, a valid assumption is that the wind did not affect the results. We assume that the wind did not affect the results. Now some of you may have noticed that the wind actually did affect the results. If you actually notice that something did cause an effect, then this is not a belief, this is knowledge, and so this is actually a source of error that comes up later. There may have been some other variable that you didn't necessarily control. For instance, the placement of the tape. How thick the tape was that you used on each of the fins, on each of the rockets. I don't know how many of you measured that. I doubt many of you did. And so a valid assumption again would be, we assume that the amount of tape used on the fins did not affect the results. The next one, a belief that the controlled variables were correctly controlled. So for instance, let us assume that you controlled, which I hope you did, that you controlled the drop height of the piston down into the launching chamber. A valid assumption here would be that you assumed that it was actually dropped from the correct height each and every time. And then lastly, let's do this one down here, a belief that the same procedure was followed for all measurements. Okay, well, how many of you switched partners when you were launching the rockets? And so one must assume that each scientist and each partner performed the procedure in the same fashion as the other one did. Now then, an assumption is not your hypothesis. It's not a suggestion that you assumed the results would come out a certain way and they did not. Okay, the results that you expect, it's not your hypothesis. All right. That is how one might use the word assumption generally and loosely in the English language, but not necessarily, and actually not necessarily, but specifically not how we're going to use it in science. Okay, we don't have clickers, so we're not going to use 1 yes and 2 no, but you do have a sheet and you can put checks in those boxes next to each of those assumptions. Decide if the following statements are correct assumption. So, the first one, it was assumed that the boys would be taller than the girls. I will give you just a few seconds to consider that. And the answer to this is definitely no. This is not a valid assumption. This is leading to some kind of result that one might have expected or a hypothesis. This is nothing to do with a controlled variable, and this is nothing to do with the way in which an experiment was conducted. And so no, this is not a correct assumption. Next, it was assumed that the wind was not strong enough to affect the paper airplane's flight. What do you think? Assumption or not? All right. In reality, yes, this is a correct assumption. This is a correct assumption because what we're assuming here, what I'm assuming here, is that the wind was a variable that was not controlled, and therefore the scientist is assuming that the wind was not strong enough to affect the paper airplane's flight. Next one. It was assumed that the swimmers all tried their best in every race. It might help to get some context to this particular experiment. Let's assume that we're testing swimsuits on swimmers, and so the swimmers all swim in a race, and each swimmer is given a different swimsuit in different races, and we see whether or not the swimsuit makes any difference. What do you think? A valid assumption or not? We would say yes, this is a valid assumption, because the fact that the swimmers may not try would obviously violate probably a procedural rule that the swimmers should probably try their best. Okay, next one. It was assumed that the nighttime data would be less precise. What do you think? Assumption or not? Is this a control variable? Or is this about procedure? I would say none of those. This is about the results, okay? Results. And therefore, no, this is not an assumption. Next, it was assumed that the same equipment was used by different scientists. Assumption or not? We would say yes, it definitely is a valid assumption. We're talking about equipment here used by different scientists, and we are definitely talking about a procedure here. So this is a valid assumption. All right, last one. It was assumed that the hungry babies would not cooperate. What do we think? Assumption or not? We're going to say no again because I think that this is looking at the results of the experiment, talking about the precision of the data set, and therefore no, this is not a valid assumption. Nearly there. Let's look about errors. Oh, I don't know why that slide is there. We're going to look about errors. Okay. A source of error. A source of error is something that definitely went wrong during the experiment. You have to know that it went wrong in order for it to be considered an error. And remember that if you know it went wrong, then it's not a belief. You know it went wrong. And so an error is not an assumption. Now, things that can go wrong in an experiment are faulty equipment, careless scientist, just like thin a pen here, careless scientist, incorrect procedure, and poorly controlled variables. And you would know that those things went wrong. Okay, they wouldn't be beliefs. You would know they went wrong. And these errors cause the data to be less accurate and less precise. Now notice that it's causing the data to be less accurate and less precise. Now let's say that you did a trial with a rocket where the rocket didn't come off the rocket launcher. And you said, you know what, I'm going to redo that trial. Well, that's totally valid, and I would recommend doing that. But if you didn't include that data in your results, then that trial did not cause the data to be less accurate or less precise. And so you cannot consider that to be a source of error. Only if you actually include the result of that trial in the data set can you say that that would actually be a valid source of error. All right, well, that's about it. You can see there's an area down the bottom. What are some specific examples of errors? Why don't you try and write down some examples of errors that may have gone wrong in your Rocket Man experiment. And with that, I bid you adieu. Thanks for listening.